Hi everybody, welcome back to Media Week. My name is Dave Vellante and I'm here with John Furrier, who's also in the house. This is NYSE Wired and theCUBE's week-long production media week of cyber and AI innovators, and one of the key innovators is where it all starts in silicon. AMD is a company that is at the heart of the innovation in AI. Ramine Roane is here, he's the Corporate Vice President of AI at AMD. Thanks so much for taking some time with us and coming into theCUBE.
Thank you very much.
So these, the proverb, may you live in interesting times, we sure do live in interesting times. We're now entering a wave. I've been around long enough to see the mainframe to PC wave, the internet wave, the mobile wave, the cloud wave, the data waves, and this one, it seems everybody agrees, is almost everybody is bigger than any of them. You guys have made an amazing story. When you finally got rid of Foundry, your business took off. You have been dominating in the x86 market, gaining share, but that x86 market is giving way to the AI market and the whole GPU wave. So where are we at with AMD from the corporate vice president's perspective?
Sure, that's a very good observation. The AI market right now is really taking over and dwarfing all the other markets for compute. And AMD actually has had a leadership position in GPUs, but not specifically focused on AI in the past, more focused on HPC. We do have, for example, the #1 and #2 biggest, most powerful supercomputers in the world. The one that was #1 up until a month or two ago was Frontier, which is built by HPE, which is based on our previous version of GPU, the MI250X, and it was the first exascale computer. Exascale meaning 10 to the power 18. It's a billion operation per second.
A lot of zeros.
A lot of zeros, and we're not talking AI operation. It's not
right.
8 bits or 4 bits, right? It's 64 bits, a billion 64-bit operation per second. But then we decided to go into AI about a couple years ago, and our latest GPU, the MI300 series, is actually optimized for AI. We started to sell MI300X this year in January, and we already generating $5 billion this year. So I think that's the official number. The most complex AI workloads on the planet are working on MI300X right now. GPT-4, that was announced by Satya Nadella at Microsoft Build, their developer conference, but also Meta announced that they're serving Llama 3 405B, their biggest Llama, exclusively on AMD because we have a massive memory advantage against our competitor, NVIDIA. We have a 2.4x HBM memory advantage because of some technology, advanced packaging technology that we leverage from the EPIC side of our world. And having a lot of HBM is very favorable for large language model, and that's why they're using that. And we're also running recommender system, search and recommendation at other hyperscalers.
A lot to unpack here. So yes, I think Lisa has put out in your quarterly earnings statements that the 5 billion number. She's also put forth a TAM number, which is enormous. And I think that's the thing that people, I'd love your feedback on this, is they don't seem to understand it's not a zero-sum game. The markets now are so big. It kind of used to be, one company, Oracle wins the database war, it's, everybody else picks up the scraps, but it's not like that in these days. It's not that way in cloud. It's certainly not that way in software. It's not that way in semiconductors, and it's even, the market's getting bigger and bigger. And so I'd like to ask you, explain the advantage that you see having from the EPIC architecture. Obviously memory is super important. NVIDIA obviously has a big lead. They have some other advantages, and I'd like to understand how you're going to close the gap. But from a hardware architecture standpoint, maybe you could describe that for us.
I would say that on the silicon and advanced packaging side, AMD does have the lead right now. In that we've been building chipletized devices for a while on EPIC. Actually, our big compute density and also power advantage came in when we started to chipletize the device into compute dies. And we also build versions where we have memory on top. So it's like a 3D V-cache, that's how we call it. But it's really 3D on 2.5D. And that's the type of technology we used for our Instinct GPUs, where we have an I/O die on the bottom that has all the I/Os and the memory hierarchy, and we have the GPU compute dies on the top, basically packing things in 3D, which our competitor is not doing. That gives us more room in the package to put a lot more HBM memory. That's how we get the
And this is a
HBM
TSM
advantage.
process? Or?
It's TSMC. We both use TSMC.
Right,
Yeah.
understood. But they, like you said, they're not doing the 3D. They had to sort of dial back down for the latest packaging just to get the thing working and get out there. So you're going right after their Achilles heel, which is power. They're expensive. They
That's
run
right.
hot.
That's right.
But let me flip that and get your perspective on this, because so chiplet size, what they would say, what some would say was, okay, but they share a big SRAM, which allows all the GPUs to talk to each other and synchronize, and it's a synchronous, whereas the chiplets have to go through memory and it's asynchronous, but you would say there's a large memory. Help us understand that. I think this is like in the weeds, and it maybe doesn't matter, but from an architecture standpoint, this is like religion. I mean, you have to pick a bet, you have to double down on that architecture, and you guys have clearly doubled down, as have most, on the chiplet architecture. And we know large SRAMs are kind of running out of gas because, I say run out of gas, they don't scale as well because they're taking up more and more higher percentage of the real estate. So that is coming to an end. But to help us understand, you know what I'm talking about here, and you can add more color because you're much more technical than I am. Help us understand the truth here.
Yeah, so there are companies who are building AI chips with only SRAM, no HBM memory,
Apple
no DRAM.
would be an example, right?
Yes,
Yeah.
I was
different
thinking
market,
on the
yeah.
data center side, I was thinking of the likes of Cerebras or Groq.
Yep, right.
But those obviously don't have the memory density. So LLM in particular, they're very big. Like LLM 70B, for example, if you're working in 8-bit, that would be 70 gig of memory. If you're working on 16-bit, it's twice more. Just to fit in the GPU memory, you have to be able to fit it. So when you're working with SRAM, you don't have that kind of capacity. So to partition something as small as a Llama 70B, you will need hundreds of chips if you're only using SRAM. And that's what those vendors do. And right now, they give that away for extremely cheap, and it runs fast, but it's not something that's sustainable. It's great, it's super fast, it's not sustainable because the cost is so massive.
The economics don't work.
The economics don't work.
But in the case of NVIDIA, they're having to push their networking in new directions to accommodate
so
this,
NVIDIA
right?
uses HBM, so
Yes, of course, right.
they have quite a bit. On the H100, they had 80 gigabytes, so the 70 would fit in that. We have 192.
Right, so you have an advantage there.
Yeah, you can fit much bigger LLM. Of course, you can always chart an LLM across multiple devices, but we can host a much bigger LLM in a single GPU.
Which means more efficient. And then
more efficient,
all across, so better
cost-effective,
price performance, better power profile.
Better power profile. For example, if you're serving a Llama 3405B, we can do that in one server, which has 8 GPUs. You would need 2 of those with the H100 or even the H200.
How about the surrounding infrastructure? How big is NVIDIA's moat from your perspective?
So most people think of CUDA when they think of the biggest moat. And turns out CUDA is actually not a moat at all, because in terms of programming language, it's C++ and we have the same. We're pretty much CUDA compatible. If you write a code in HIP, which is our CUDA, it will compile in the NVIDIA compiler, and it will run on NVIDIA hardware, as well as compiling in ROCm, our software, and running on AMD hardware.
So you've been able to neutralize that moat through code.
Yeah, but then people would say yes, but they have a lot of libraries. They've been writing libraries for 15 years.
What about that?
So the thing is, those libraries do run on the next GPU from an older version to a newer version of the GPU, but they don't run at performance. So all these libraries have to be rewritten at every generation. And right now, we're both at a cadence of building a new architecture every year.
Every year.
Yeah, so it's a completely new architecture every 2 years and a incremental upgrade every year. So every year, we have to actually rewrite the libraries so they run optimally.
Oh, interesting.
So that's why there is no moat.
Yeah, we don't hear that fine print on the earnings call, but they do make, NVIDIA, Jensen makes a big deal out of the backwards compatible, the forward compatibility, but there's work that has to be done.
There's work. So obviously they're very good at it, they're very fast at it, but it's not as much as a moat as people think because everything has to be redone.
But I would say, so that's great context. I would say the other moat is the systems expertise.
That's
you
correct.
guys acquired Z Systems, which I thought was a brilliant move. And it's in recognition that this is a systems game. It's not just about the chip and making the chip go faster. Yeah, that's part of it. But there's other, so why is systems design so important? Why is the Z Systems acquisition relevant?
Yeah, so right now with the current generation of GPUs, most cloud service provider buy servers that they put together in a rack and they build a cluster and so on. In the future, NVIDIA is trying to sell racks, like 72 GPUs, and we're going that way as well. So we'll have both servers and rack scale. ZT Systems basically provided clusters, build clusters for hyperscalers, like the biggest of the hyperscalers. So they do have this expertise. They're among the best in the world. So because in our roadmap we have our next generation GPU that will have that rack scale capability, we wanted to bring in the expertise from ZT Systems to build those products and make sure that it has all the features needed that hyperscalers are looking for.
What should we know about networking, both networking within a system on chip and internetworking between, across clusters? What should we know about that? I mean, obviously the Mellanox acquisition was catapulted NVIDIA's business, but Ethernet, certainly we were at reInvent last week, I guess 2 weeks ago, because we're publishing this next week. All the hyperscalers using Ethernet as their back end. It's a standard. Right. It runs the internet. Don't bet against Ethernet is probably
right.
a good bet. What should we know about networking? What's AMD's point of view on this?
So NVIDIA uses NVLink to interconnect GPUs locally, and then, as you said, they have Mellanox with InfiniBand to scale out. We have what we call the Infinity Fabric to interconnect our 8 GPUs, for example, in a server. And we're going with Ethernet, and Ultra Ethernet is coming, which has better metrics than InfiniBand.
Even NVIDIA is going
even NVIDIA
Ethernet.
is going Ultra Ethernet, exactly. Yeah. And a protocol like Rocky V2, for example, today with regular Ethernet is actually pretty good as it is. Ultra Ethernet will be significantly higher. So, and obviously Azure is deploying us, Meta is deploying us, other hyperscalers are deploying us. They all use Ethernet, and looking forward to run even faster with Ultra Ethernet. Yeah.
So it really comes back to this market is so huge. I also want to tap your brain on training and inference. I mean, I think we years ago, even before Gen AI hit the market, said that we felt like inference was going to be the big market and the most use cases, especially when you start thinking about edge applications. How should we be thinking about inference. And it's funny, NVIDIA says that a very large portion, I forget the exact number, maybe close to half of its enterprise business is inference. I've always assumed that's running ChatGPT, queries. So, okay, that's inference, but there's other inference, as I say, out at the edge. How do you think about the training versus inference? Are they simpatico? Are they different markets? What kind of architectures are required? Obviously, there are cost consideration. Help us squint through that.
Yeah, initially we thought inference would be significantly bigger than training, and it kind of will be, right? Makes sense, because you train a model once and then you infer it at scale.
Right.
But models are becoming so big right now that training the latest, greatest LLMs, the massive LLMs, are taking a lot of resources, a lot of training resources. So training is still pretty big.
Sucking up a lot of demand, yeah.
Yeah, in terms of compute resources. But yeah, definitely inference is getting bigger. It is getting bigger. As far as our GPU goes, our GPU does both, just like NVIDIA's, but we decided to go primarily with inference first. So the ChatGPTs and Llama 405Bs and the recommender system, they're all on the inference side. We have started to work with some customers in training, and we are seeing near linear scaling when you need, when you go from one GPU to hundreds to thousands of GPUs. So our GPU can really do both now. Whether we're going to have inference specialized GPUs versus training specialized GPUs in the past, in the future, it's a possibility. But right now, the intersection is pretty big in terms of what you need.
I wonder, when you mentioned, you said scaling, you're talking about the GPU scaling, but there's also the scaling laws. And I want to ask you about this, because the economics of training large language models is terrible. I mean, I think it was $190 million to train Gemini Ultra. Now, of course, it had a big context window. I understand that. What Elon's building with Colossus, if it's really 100,000 GPUs, it's got to be billions of dollars to train. And so maybe if you're not familiar with the scaling laws, it's really just the bumper sticker is you got to have compute, you've got to have data, and you've got to have parameters, which is the weights and the biases. You got to have all three in order to scale. If you just try to scale compute without the data or the parameters, you run into diminishing returns. And so we think that whatever Grok is doing in Memphis will prove or disprove this next generation of scaling laws. We'll see. We'll see. But irrespective of that, the economics are very expensive. The costs are very expensive. The price per token has come down, in GPT-3, 3.5 has come down 4 orders of magnitude in 3 or 4 years. GPT-4 is on a path to come down 2 orders of magnitude in 24 months. So cost is going through the roof, price is coming down by orders of magnitude. I mean, it really, really tough economics. Now, if you're Facebook, or Google, you can sell ads with bigger GPU clusters mean you can sell more ads, I guess. Okay, so the economics for consumer maybe not so bad, but enterprise AI, different story. You're going to have to show ROI there, and that's really the market that ultimately you're kind of going after with, I would think, with inference. More cost-effective, lower power, very, very high volume. What are your thoughts on all that? See, I see them as 2 different markets. The big LLMs who are sucking up all the demand right now, and that's wonderful, but that's it's going to be lumpy. At some point, that's going to end. But the real interesting opportunity when you think about NYSE and all the companies in this financial district is really enterprise AI. What are your thoughts on all that?
There's a lot to unpack there. Yeah. So first, about the scaling laws. I mean, are we running out of data, for example?
Yeah.
Yeah, I think a lot of the data which is publicly available has been used already to train those massive LLMs. Of course, there is a lot more private data out there. That's one source of data.
Yeah, if I could interrupt, sorry to do that, but because people say, well, the LLMs, they can run synthetic data, but that's fine. But that synthetic data is different from that private data. That private data is never going to get into those LLMs, I hope.
Right,
Yeah.
right.
So sorry to disrupt your
But
thinking.
beyond synthetic data, when I'm talking data here right now, it's text only, right?
Right.
So fine, let's say we trained the latest GPT on almost all of the text ever written by humanity, which is public.
Right.
However, those models are now multimodal, so they also run from images, and if you take the case of Sora, it's also learning from videos.
Right.
So now the source of new data is almost infinite.
Yeah, okay.
And really, when you think about it, GPT-3, for example, was trained on a lot of text, right? More text than you and I can read in the next 100,000 years or million years. But probably when we were 5 years old or 9 years old, we could do a lot more than GPT-3 because we learned from vision, from seeing things, from experimenting with the laws of physics and breaking things, right? GPT never experienced these things. With video, now it can.
I see, yeah.
And I think it's going to keep on going. There's going to be touch, there's going to be hearing and smelling, which is analyzing the molecules in the air. So there is an awful lot more data to
all
train
those
on.
human senses are
All
going to
those
get
human
digitized. That's a
senses, yeah.
really, I had not thought about that deeply. So,
That-
okay,
that's-
so we're not going to run out of data.
And I believe that's really what you need in order to get to what they call AGI. You need to be able to learn from all the different senses. Of course, the one thing the LLMs will never have are the hormonal responses, but everything else at least should be available to
And
LLM.
I have to ask, where are you personally? Don't make this AMD's opinion, but you know, some pundits and experts feel like we'll have AGI, you know, before the end of the decade. Others say, no way. Do you have an opinion?
Okay, so again, that's not AMD's opinion. I think in the next 10 years it's possible. But we have to define AGI. I think it's really having the breadth of learning new tricks that humans have. For example, when you're 16 or even 14, I can teach you how to drive a car in like a few hours, right? Show how, especially if there's no stick shift, it's even easier.
Right.
I can show a 14-year-old how to drive a car for a few hours and then put him at the driver's seat and he will drive. No AI really can do that today. If I put the latest, greatest LLM in a robot and say, hey, I'm going to show you how I drive, and now you're going to drive in New York City, we're going to have a crash, a really bad crash. So are we going to get there in 10 years where I can put an AI in a robot's brain and it can learn how to drive a car, whereas it wasn't trained for it?
Maybe.
Conceivable, yeah, but we will get there. It's just a matter of when.
The technology exists, and if you look at the exponential growth, I agree, we will get there. It doesn't matter. But you're bringing up a great point. There's a reason why we don't let people drive until they're 16, right? Their brains have to mature. They learn from surroundings. They observe.
That's right. They experience with the laws of physics for 16 years, and now we trust them, right?
And that's why full self-driving is maybe taking longer than a lot of people expect.
Right.
I mean, you're a fantastic guest. I can't thank you
so much
for coming on and being so candid. And best of luck. I hope we can have you back on in the future.
Thank you very much. It was a pleasure.
All right, and thank you for watching. This is Dave Vellante for John Furrier in theCUBE and NYSE Wired's Media Week, AI and Cyber Innovators. We'll be right back right after this short break. You're watching theCUBE.